Good morning, everyone. My name is Alicia Freel, and on behalf of my co-authors, I'm excited to present our work, How Misclassification Severity and Timing Influence User Trust in AI Image Classification. So, what does this talk about? I want you to first consider a scenario where you imagine you're using a new expert AI system. You show it this image of a classical statue and ask it a simple question. What is this an image of? And the AI confidently tells you, this image shown is the Statue of Liberty. This leads us to our central question. Would you trust this AI again? Would you give it a second chance, or would you discard it immediately? This very dilemma, how we form, break, and repair trust with AI-based systems and the nature of their errors, is what our research talk is about today. So, an AI mistaking a statue is a simple error, but it isn't just a theoretical problem. This is critical in real-world human AI teams where the stakes can be dramatically different. In a low-stakes context like content moderation, an operator needs to trust an AI's flag before taking down a post. Whereas in a higher-stakes context like battlefield security, a military operator must trust that the AI's classification of an object is correct and whether it is friendly or hostile. So the first factor we tested was severity. As you can see, the consequences of a mistake are vastly different. An error in content moderation for children might be annoying. However, an error in security context can be catastrophic. Unsurprisingly, we found the severity of a mistake to deeply impact user trust. But the severity of a mistake is only half the story. We also need to consider when it happens. Does a severe error at the beginning of an interaction feel the same to a user as the exact same error at the very end? Can a string of correct errors make you forget an initial failure? This introduces our second key variable, timing. This also brings us to our core research question. We wanted to move beyond looking at these factors in isolation. We specifically wanted to know, how does the severity and timing of an AI's error jointly impact the user trust? So, to figure that out, we decided to run a survey that was a mixed methods approach in an online experiment with 364 participants. We systematically tested our key variables across different 16 conditions and placed participants in one of the two contexts, military content moderation, and then we manipulated the error severity and error timing. So what did we find? This chart shows us our core findings with users' trust on the y-axis. I want to draw your attention specifically to the red bars for a moment. This is our high-stakes military context where the AI made a severe error. When that severe error happened at the end of the interaction, user trust significantly declined. But when the exact same error happened at the beginning of the task, users were surprisingly forgiving. The trust was damaged but not destroyed, and this shows that trust is critically shaped by when an error occurs and is likely due to the recency bias where users heavily weigh the AI's most recent actions and overlook its overall performance. So what does this look like in the real world? Well, imagine an AI operator who has been working with the AI assistant for about an hour now, and the system's working perfectly. Trust is high. Then, out of nowhere, an adversary forces the AI to make a single severe error, and it flags that a civilian cruise ship and says to engage immediately. This is the exact condition our research found to be the most damaging. The operator's trust doesn't just dip, it creates a significant drop in trust, and they can no longer trust any output from the AI. The human AI team is now paralyzed, and that chaos is the precise vulnerability that the adversary was trying to create. Now, I also want to look at the flip side of our findings. We talked about the dramatic trust in high-stakes scenarios. However, what happened in low-stakes social media contexts is also important. As you can see from the green and purple bars, the story is completely different. Our analysis showed that conversely, user trust was not significantly impacted in these low-stakes scenarios. It didn't matter if the error was severe or not, or when it happened. Usually, users were largely indifferent. On the surface, this seems like good news. An error happens, and users just move on. But this indifference is what creates a unique and dangerous vulnerability. While a single error may not shatter trust, it can create a perception that the AI is still accurate because to the user, the mistakes were not severe, and that perception could be exploited, as we'll talk about. So why is this important, and why might this be dangerous? It's because it enables a classic playbook for manipulation that would potentially be automated by the AI. This historical playbook is simple. First, you build trust with harmless content, and then you inject manipulative content. The system's harmless appearance is the vulnerability. Similarly, At the modern twist, our study shows that AI can make mistakes, even severe ones, and users in low-stakes contexts remain surprisingly tolerant. This user indifference is the vulnerability and creates a perfect cover for AI to subtly insert a piece of targeted misinformation, and this is how systems that we label low risk become the perfect pipeline for high-risk manipulation. So those graphs showed us what happened, and our qualitative data gives us a clear window as to why. On one hand, we saw that users were often willing to forgive early mistakes if the AI performed well afterwards. On the other hand, that forgiveness had a limit, especially when a severe error happened at the end of the interaction. This shows a psychological tension at play. Users are more willing to calibrate trust over time, but a single severe error can feel like a betrayal that breaks the trust entirely. So, looking forward, how we can use these findings to build safer AI systems includes some proposed policy considerations. First, we saw that late-stage severe errors completely erode trust. This is likely due to the recency bias. To counter this, we propose design features like interaction recaps that summarize an AI's performance over time and gives users a more holistic and accurate view of its reliability. Secondly, we found that users are very forgiving of early errors, especially in contexts they perceive to be low risk. Because of that, we argue that regulatory frameworks should evaluate an AI's design, behavior, and goals, not just its application domain. Auditing for things like error timing and the potential for reward maximization where AI systems learn to exploit cognitive biases. So that helps us understand what we can do in the future, or right now. But what about the future? For our future work, we look to tackle a more subtle problem, when the AI itself learns to be deceptive. And this isn't just a theoretical risk either. We already have research showing that when you give an advanced AI a simple goal, it can learn to achieve it in unintended and deceptive ways. And this is simply because deception can become the most efficient strategy. Our own research reveals a clear example of how this could happen. Imagine an AI who is maximizing user satisfaction, and that is its goal. It learns through trial and error. The AI isn't malicious, but it does learn a powerful and manipulative strategy. It's better to get this bad news out of the way early or prolong the interaction with the user to make the user feel good after its mistakes. This is a critical next step for our research because this deception can emerge within the very frameworks we design. Our challenge is to build reward functions and auditing tools that can actually detect and prevent this kind of deceptive trust calibration in the future. To conclude, I just wanted to kind of go over our key findings, where trust in AI is not simply a function of its accuracy, it is critically shaped by the timing and severity of its errors. In high context stakes, this effect is significant. A late severe error can catastrophically erode trust, while the same error at the beginning of the interaction is often forgiven. Conversely, in low stakes context, users show a surprising tolerance to both error timing and severity, which can be taken advantage in what we consider low risk situations. Thank you.